the furthest point of distinct vision of a long-sighted person is infinity. This person is used a magnifying lens to view close objects. He finds that he can see clearly magnified image of an object if it is held anywhere between 50 millimeters and 60 millimeters from the lens, but nowhere else. His least distance of distinct vision is. His minimum visible distance is 50 millimeters. We can get object distance 50 millimeters. We have to find the image distance, and first of all we have to get the focal length by using the second data. Second data means its maximum visible distance is 60 millimeters. It means we can see infinity without using magnifying lens. By magnifying lens, an image should be formed at infinity by using an object at 60 millimeters. Therefore, the focal length of the magnifying lens should be 60 millimeters. We know that by a lens, an object, when bring an object to the infinity, the object distance should be focal length. And we know that magnifying lenses are convex lenses, therefore this one should be minus. Then we can use minus 60 for the focal length. All values are in millimeters. Then we have to find V value. V value is the least distance he can see without using magnifying lens. Then we can use 1 over V minus 1 over U equals 1 over S. Image distance is the problem. Object distance 50 millimeters. Focal length 60 millimeters, but it is a minus value. Then we can find V minus 1 over 60 plus 1 over 50. LCM of denominators 300. 300 divided by 60, 5 minus 5 plus 300 divided by 50, 6. Then we can obtain V value is 300 millimeters. Then answer should be 4. The near point of defective eye is 50 centimeters and the lens that should be worn to correct near point to 25 centimeters. By the wearing lens, an image should be formed at least distance he can see, 50 centimeters, by using an object with 25 centimeters. We have to find focal length. Then 1 over V minus 1 over U equals 1 over F. Lens formula 1 over image distance is 50, object distance is 25. We have to find F. LCM 50, 50 divided by 50, 1 minus 50 divided by 25, 2. Then S value is 50 divided by minus 1, it means minus 50 centimeters. Then it should be a converging lens with 50 centimeters focal length. Then answer is 1. A normal eyeball has a diameter 2 centimeters as shown in the figure. The magnitude of minimum power of the eye lens is. We know that we can obtain minimum power for the maximum focal length. It is for C infinity. It is like this. Light rays from infinity are focused into retina. Then focal length should be 2 centimeters for the maximum focal length. It means minimum power. Then we can write power 1 over focal length. 1 over focal length 2 centimeters. We have to convert it to meters. 100 divided by 2, 50 diopters. Then answer is 4. The far point of near-sighted eye is 50 centimeters. In front of the eye to see clear object at infinity, a lens is worn 2 centimeters in front of the eye. The lens should be. We have to find the lens type and focal length. By the corresponding length, an image should be formed at 48 centimeters because of eye lens is 2 centimeters behind the eye. We can see 50 centimeters from the eye. Therefore, image distance for this lens should be 48. Object distance should be infinity. It means focal length should be this one because of we know that we can bring objects in infinity to the focal point of lens by using a lens. Then focal length should be 48 centimeters. And we know that we are using to see infinity diverging lenses. Then it should be a diverging lens like this, and focal length should be 48 centimeters. Answer is 5. A person cannot see clearly the object beyond the distance of 50 centimeters from his eye. In order to see distant object, he must wear. The image should be formed at 50 centimeters by using the object at infinity. Therefore, focal length should be 50 centimeters and it should be a concave lens. It is like this. Then answer should be 3. The distance from eye lens to the retina of a person is 1.7 centimeters. The focal length of the eye lens when the eye is compulsory relaxed position. Eye is in relaxed position. It means he should see infinity. When see infinity, we know that parallel rays are coming to the lens and an image should be formed on retina. Then focal length is this one, 1.7 centimeters. Then answer is 5. A patient with cataract got his eye lens replaced by an artificial lens that has a fixed focal length. After surgery, his vision was then found to be best for views object at a distance of 10 meters. The lens that should be used for reading is, we have to find the lens he has to use for reading. Near point is given as 25 centimeters. Then an image should be formed at 10 meters. It is the his near point of distinct vision after the surgery. Object should be placed at 25 centimeters. We have to find the focal length. Then we can use 1 over v minus 1 over u equals 1 over s. 1 over v is image distance, it is 10 meters. 10 meters means 1000 centimeters. U value 25 centimeters, we have to find s. Then we can get the LCM. 1000 divided by 1001 minus 1000 divided by 25, 4. 4 into 1, 4. F value is 1000 divided by 3, it is minus. Approximately minus 25 centimeters. Then a convex length of approximate focal length 25 centimeters. Answer is C. A person suffering from farsightedness has his near point located at 150 centimeters from the eye. After wearing contact lens, he could read clearly a book held at distance of 25 centimeters. They used contact lenses. Again we have to use lens formula. 1 over v minus 1 over u equals 1 over s. An image should be formed at its near point of distinct vision, 150 centimeters. U should be 25 because of he is using contact lenses to read a book. We have to find focal length. SCM 150, 1 minus 6. Then S value is minus 30 centimeters. It means he has to use convex lens with 30 centimeters focal length. Answer is 4.